Hello everyone, this is Mrs. Shaw, and on today's lesson we are going to continue talking about a system of equations. What are we looking for when we're trying to solve a system of equations? We are looking for one pair of numbers that will balance both equations. So we are looking for an x and a y that when we plug that x and y into both of these equations will be true. They will both stay balanced and be true. There are 5 different methods that we have that we can use to solve a system of equations. We've talked about a few of them. We can use tables, where we show tables and find out which, if there's a point on both that's the same on both tables. If we have a table of these equations, we can graph both equations and see where they cross. That's what our assignment was yesterday. Today we're going to start talking about substitution. Another way that we will still learn is elimination, and another method is matrices. We've been solving with graphing, but when would graphing not be helpful to use as a way to solve? If we think about that, if we didn't have graph paper handy, that would be when it wouldn't be the easiest. Also, maybe if the equation's not in slope-intercept form, but sometimes they are, and we're graphing them, the point might be clear off the graph where they can cross, and so it might be hard to figure out if it's off the graph, what is that point? Another is if the graph might be somewhere, maybe it's a fraction or a decimal where they cross, and we don't know exactly what that is. So there are different times when solving an equation might not be best using graphing. So we're going to talk about solving an equation using substitution. So using substitution, if you think about substituting, there's a substitute hitter in baseball, or there's a substitute teacher if the teacher's not there. And what it would be is if the teacher's missing, then there's something that goes, the person that's there to replace them for the day. So looking at substitution, let's start off by looking at these 2 equations. We have y equals 3, okay? Y equals 3. We know that y and 3 are equal, so what we're going to do is in the next equation, we're going to take what y is equal to and replace it for the y in the next equation. So this second equation, we don't have, if I wasn't there that day, the teacher wouldn't be there, I would have a substitute, and the substitute would be in my place. So I'm going to put the y equals 3. The 3 is substituting for the y. So now we have 3 equals 2x minus 9. Now we have an equation with one variable, with our x. And we can do our chore chart. And we're looking for solving for x. X is being multiplied by 2 and then subtracting 9. We're going to work backwards, and we're going to start by doing the opposite of subtracting 9, which is adding 9. And we're going to add 9 to both sides. 9 plus 3 is 12. Remember, we're going to keep our equation balanced. And 2x, we have our negative 9 plus 9 cancels. We're doing, that chore is done. We're doing our next chore. The opposite of timesing by 2 would be dividing by 2. So we're going to divide both sides by 2. And 6 equals our x. So we have solved now the x part of our answer here. So our answer will be in ordered pairs, an x and a y, and we say that x is 6. We already started off with knowing our y is 3. So the 0.63 is a solution to these two equations. Well, how do we double check that that's correct? Let's go through here and plug them in. We're going to know if these are correct, they should work for both equations. Well, y equals 3. Here we said that if we put 3 in here for our y, is 3 equal 3? Yes, this checks. This next equation down here, our y, if we put our y is 3, I'll write it down below, is that equal to, what did we say our x was? 6. And we'll see if this stays balanced, if this is a true equation here. So 3 equals 2 times 6 is 12. 12 minus 9, does 3 equal 3? Yes, this checks. So this set of numbers works and is true for both of these equations. Let's do another example here. We are looking for an x and a y that will work and be true for both of these equations. Well, here we can see now that they told us in one of the equations that x equals -2. Well, we've already got this answer part right there. Our x is -2. And we're going to use substitution and substitute what we know about x. We're going to substitute it into the other equation where we have an x. So now I'm going to rewrite this first equation. I'm going to rewrite it instead my y. I do not know what y is. Y equals 3 times, what did we say that it said x was? I'm going to use parentheses so this negative doesn't confuse us. We know we're multiplying. 3 times -2 minus 9. And I'm going to simplify this here. Y equals 3 times -2 is -6. -6 minus 9. Y equals -15. Well, that could be our answer, but we better double check. We can double check by plugging the set of numbers here that we have. The set of numbers that we got here as our answer. We're going to plug these in to both of these equations. Well, let's start with the basic one here. X equals -2. If I say x does -2 equal -2, yes, that one checks. So let's start with look at this top equation. We say our y, maybe I'll use a different color here. Our y is -15. So I'm going to plug that into the y, okay? So -15, is that equal to 3 times, oh, here's our x. Our x is -2. 3 times -2 minus 9. So let's see if this is, we're checking. Is this going to be a true, will this stay balanced? Will this be a true statement here? -15 equal to, let's see, 3 times -2 is -6 minus 9. We have -15 equals -15. And yes, this checks. All right, so our next example here, we have y equals -x minus 4. Here, y equals -x minus 4. There's a y in this equation. Can we substitute this -x minus 4? Can we substitute in that? Let me clarify this a little bit better here. Let me just do this again. All right. So y equals -x minus 4. I'm going to substitute that in the other equation where the y is. So I'm not going to write the y that's in the second equation because I'm going to substitute it with now what I said that y is equal to. So I'm going to substitute -x minus 4. I'm going to substitute it into this y. So this y will not be there. If I was gone, then I would get a substitute, and the substitute would be there. And so we have -x minus 4 is replacing our y in the second equation. And here we're still going to write down the rest of the equation, -2x minus 3. Now I'm down to an equation that I only have x's, but I do have x's on both sides. So here's where we're using what we were learning in Unit 2 and solving equations. We have x's on both sides. We can't quite do the chore chart yet because we need to get our parents on the same page here. And we have x's on the left, x's on the right. I am going to take my smallest coefficient, which is this -2, and do the opposite, and I'm going to add 2x to both sides. Our -x plus 2x is now 1x, and I have -4 still. I keep writing down there, I keep them lined up, equals -2x plus 2x goes to 0, and we have -3. Now I'm down to x minus 4 equals -3. This is where I can do the chore chart because I have 1x in this equation. My x is being subtracted by 4. So if I want to do the opposite of that, we only have one operation. We're doing the opposite of subtracting 4 was adding 4. We're going to do that to both sides of this equation, and our x equals -3 plus 4 is 1. Our x equals 1. Well, we're going to put up here x equals 1. Now, we don't know what our y is. How are we going to figure out what we figured out what x is 1? Let's decide what do we need to do to figure out what y is. Well, looking, I have two equations here I can choose from, and I can actually just choose either one of these equations and plug my x being 1 into one of them. So I'm going to choose, this top one looks pretty good. I'm going to take my x as 1 and I'm going to put it right in here for this x in this equation. So I'm going to write down, so y equals negative, my x was 1, that was 1, minus 4. Okay, well, y equals, oh, I should have done this over here. I'm just going to rewrite it over here. Y equals -1 minus 4. So y equals -5. We have now figured out that the y is -5. But we are going to double check this. We need to check that this, if this is true, if this is the solution, if this is the solution, that means these points work in both equations. So we need to double check that these, when x is 1 and y is -5, that is true for both of these equations. So I'm going to take, we already did it on the first one. Well, we'll do it again. We'll do it again. We're going to check here. Instead of writing y, we're going to put our -5. Okay, and instead of writing our x, x is 1, and we're going to see if this is true. Is our -5 equal to -1 minus 4? -5, if this is our question, we're checking if this is true. Okay, does it stay balanced? Is -5 equal to -1 minus 4? -5 equal to -5? Yes, it is. We also, in order to be this a solution for this system of equations, these have to be true for this second equation as well. So we're going to put the -5 in for this y. Let me erase this at the top here, because now we're checking it out with our -5. We're going to put it into this one right here. And we're going to put our 1 into this x right here. So -5 equals -2. Our x was 1. And we have -3. -5 equal to -2 times 1 is -2 minus 3. Is -5 equal to -2 minus 3 is -5? Yes, it is. So this set of numbers, now I'm going to erase. That was 1 and -5. 1 and -5 were the pair of numbers that worked and kept both of these equations balanced. They were true for both of these. Another example here. We are going to solve by substitution again. What's really nice when you're solving by substitution is if you already have one of your variables set as equal. So here on the second equation, we have y equals x minus 1. Well, I'm going to take this y equals x minus 1, and I'm going to plug it into the first equation where the y is. So this one's going to be a little bit, I've got to be very, very careful. I'm going to rewrite this first equation. Let me use maybe a different color. I'm going to rewrite it down here. And so I'm going to rewrite it as 2x minus 3. Oh, instead of y, I'm not going to write y. I'm going to write my x minus 1. This was my substitute. All right? Instead of y, I'm writing x minus 1 because that's what y is equal to in the next equation. So I'm going to finish writing this first equation, 2x minus 3 times y, but we put x minus 1 instead because we're substituting, equals negative 1. So I rewrote this first equation right down here with x minus 1 substituting in for the y. And now we're going to do back what we did in Unit 2, and we're going to solve for x. So we're going to simplify this and write 2x. We have here our subtraction. That is the same as adding the negative, and we're going to distribute that through these parentheses. So here we have our 2x. We have plus, plus negative 3 times x is negative 3x. That was the first one we did here. And negative 3 times negative 1 is a positive 3. We have our equals negative 1. We're still simplifying. We have these x's that are on the same side of the equal sign, so we're going to combine like terms. Negative 2 plus 2x plus negative 3x is negative x, or negative 1x, plus 3 equals negative 1. Now I can do my chore chart. Whoops, I'll switch color here so it's not as confusing. Our x here is being times by negative 1 and then added with 3. Remember, we're going to work backwards and start at the bottom and go up. The opposite of adding 3 is subtracting 3. So I'm going to subtract 3 from both sides here. Keep my equation balanced. I'm going to have negative 1x. 3 minus 3 is 0. Equals negative 1 minus 3 is negative 4. I did that job. The last thing I need to do now is do the opposite of times negative 1, which would be divide negative 1. And we divide both sides by negative 1. And we end up with x equals negative 4 divided negative 1 is positive 4. So our x we figured out in this system is 4. We need to go figure out the y now. So I'm going to clean up all this mess here. And we're going to take what we know for x. Our x is 4, and we're going to plug it in right here. I'm going to use the little simpler equation. You can use either one. This one looks a little simpler to me. And I'm going to write our y equals, instead of x, we figured out that x is 4 minus 1. So if y is equal to 4 minus 1 is 3. Oh, that one was much simpler. So our y is 3. So when our x is 4, our y is 3. Well, we need to double check that. We did just check it in the second equation. So this time I will just go through and double check it for our first equation here. And how I'm going to do that is I'm going to take my x is 4 and plug it in here for my x there, and my y is 3. And I'm going to take that and plug that right in here for this y. So I'm going to rewrite this equation over here, and I'm going to have 2 times, I said my x was 4, and subtract 3 times, and our y, we said, is 3. Maybe I should have done those different colors. Here was our x, here was our y. And that equals, so we're still writing this equation, negative 1. So I just rewrote this equation right here, and I just rewrote it. Instead of x, I put our 4. Instead of y, I put our 3. And now we are going to see if this is true. 2 times 4 is 8. If it helps, we can do, let's see, add a negative, if that helps people. Negative 3 times positive 3 is negative 9. So that would be adding negative 9. Does that equal negative 1? Is 8 plus negative 9 is negative 1 equals negative 1. Yes, that checks. So this right here, this set of numbers where x is 4, y is 3, this ordered pair, 4, 3, is our solution to these two equations. On this one, our level 3, I'm just going to get it started for you and let you work it out. But the reason it's a level 3 is we're going to solve this using substitution. And in order to have you solve using substitution, we need to either have one of these equations say y equals, or one of them say x equals. So I'm going to look at these two equations and determine which one might be simpler to solve for x or solve for y. This has a few more steps in it, so I might look at this first one. What would I need to do? What would I need to do to get either y equals or x equals in this equation? Well, I already have x plus 3y equals 1. So how about, I'll do this equation. If I were to subtract, let me rewrite this equation so you can see it. X plus 3y equals 1. If I were to get x by itself, I would need to subtract 3y. Here's, keep it balanced. I got to subtract it from both sides. It's not a like term with 1, so I'm just subtracting it over here. Okay, so we are going to have our x equals, because 3, whoops, I should keep it in line. Let's line that up. Our x, 3y minus 3y goes to 0 equals, and 1 minus 3y. Now I have an x equals. I'm going to solve this by substitution. I know now what x equals, and I can take what x equals and I can substitute that right in here for x. So I will help you get this set up as an equation and then let you finish with this. So I'm going to start with a new color here, and I'm going to rewrite this equation, but instead of x, I'm going to write our 1 minus 3y. So we have here negative 3, but instead of x, I'm going to write, I'll change colors here, 1 minus 3y. So we have negative 3 times x, but that's 1 minus 3y, we substitute it, minus 3y equals negative 15. Oh, I've got too much on here. Let me erase some of this. Okay, so I'm writing this equation that's here, and I'm just writing it down here. I have our negative 3 times x. We decided what x was, and minus 3y. So I'm rewriting this here, and equals negative 15. So everything is just, I'm just rewriting this whole statement here, this whole equation. And down over here, this was what our x was equal to. So making sure that's in here. And we can see that I'm taking what x was equal to and I'm substituting it right in there. Okay. In order to solve this one, and I just rewrote this equation down here. In order to solve it, you're going to need to distribute and then simplify and solve for y. Once you get your y, you're going to go back in to one of these equations and solve for x. This will get you started on it. These are some extra steps. That's why this one's a level 3 using substitution. And good luck and have a great day.